Section 2.3, Math 1111. In this problem, the volume for a cylinder is V equals power squared H. Find the volume of a cylinder with a radius R of 9 and a height of 7. Answer exactly using pi or pi. So they want us to leave pi the answer. So basically, here we go, folks. It equals pi r squared H. So they told us that the radius is 9, right? So that's 9 squared, and the height is what? So, so that's pi times 81 times 7, which is, anybody got an answer for that? Do 81 times 7. So that would be 567 pi. That's volume, so it'd be cubic what? Centimeters, right? Cubic meters, right? Cubic meters. No, cubic centimeters, sorry. You're right. Yeah, 567 pi cubic centimeters. Questions? It's just a chug and plug. You plug the, substitute the stuff in, evaluate it, and just leave it in terms of pi. Any questions? I do. They probably won't have you do that for the units, but that's just good math to put the units. So yeah. All right. Solve for W equals perimeter equals 2L plus 2W. So solving for W would leave us with what? Let's see. Perimeter equals 2L plus 2W, and if we subtract 2L, then we get P minus 2L equals 2W. And then, of course, we'll divide everything by what? 2. So W equaled P minus 2L divided by 2, right? So that's solving for, so this satisfies that little bit, right? Then it says use the formula from above to find the width of a rectangle whose length is 10 and whose perimeter is 34. So that'd be 34 minus 2 times 10 divided by 2. So that would be 34 minus 20 divided by 2 equals 14 divided by 2 equals what, 7? So I got 7. Y'all good? No? All right, what part? Oh, in the problem, right here. Right there. So it told me whose length is 10, whose perimeter is 34. So 34 minus 2 times L, and L was 10. So that'd be 14 divided by 2, which is 7. Y'all good? Okay. All right.
That's basically the formula.
All right, guys. Well, let's look at the next one. This one is, again, just a chug and plug type problem. The formula F equals mv squared over r, which relates to force, the velocity, mass, and resistance. When find r when m equals 54, v equals 7, f equals 441. Well, we're going to do an algebraic technique here. They want us to find r, right? And when you remember, we talked about ratios. If you got two ratios set equal to one another, you got proportion, right? So you can cross multiply. Well, that's true, but let me tell you what's also true. Diagonals can flip places if you have a fraction equal to a fraction. So what I'm about to do is this. Right? If I multiply both sides by r, then divide it by f, I get that, right? Yeah. So knowing that algebraic technique, that diagonals can flip, they can swap places, allows you to solve it in terms of r very quickly. Now, from this point, it's just a matter of, let's plug in numbers. So that's 54 times 7 squared all over 441. So that leaves me with 54 times 49, which would be 2646, all of 441. Uh-oh. Ladies and gentlemen, the resistance is 6. And if you don't get technical, that's 6 ohms, right? Because resistance is in ohms. So it's supposed to look like a mega, but it didn't. So, all right. Okay. That is the homework. No, nah. That's just my electrical engineering coming out. Yeah, just food for thought. Yeah. Yeah. Yeah, it gets kind of peculiar. Yeah, inputting these. But if you do that little 7-question thing that they have you do the intro or whatnot, it tells you how to type things in, right? Isn't that basically what the intro does, right? Yeah, but you still, I mean, 7 problems can't encounter everything. Okay, y'all good on this one? The biggest thing is that algebraic technique, the diagonal, right? So, and a lot of this stuff you haven't seen in a while. So, just kind of brushing off the cobwebs. All right, I'm going to do this in the easy way. I tend to teach it a little differently if I had time. But 2 consecutive integers is x and x plus 1, right? So this is a sum of 2 consecutive, so that would be x plus 1 equals 7, right? Find the numbers. So that's 2x plus 1 equals 7. And then that is, we'll just solve this equation. 2x equals 6, x equals 3, right? Because I divided both sides by what? 2, right? So the smaller of it would be what? X is 3, then that would be 3 plus 1, which equals what? 3 and 4. Questions? Would you probably see that one again? Huh? Well, yeah, I normally do it 2n and 2n plus 1. 2n and 2n plus 1 and 2n plus 2. I do it with, because that way n takes care of if it's an odd or an even. Sometimes they get more complex and stuff, so I kind of go to a different formula. But they just keep it simple. Will you probably see one like this again? Yeah, first 5-6 years that I taught college algebra, there was one like this on the final. So I haven't looked at the final here lately because I haven't taught the class. So, but yeah, if I was betting, man, I bet that was probably on the final. Yes, maybe 3 plus 1 equals 4. That's going to get your next consecutive number. It's like a sequence. X plus 1, X plus 2, X plus 3, X plus 4. Stuff like that. So, but good question. All right, now, this one right here, I worked 5 or 6 ways. And I kept getting it wrong. And so I'm going to let you see. I want to see if you fall into the same hole that I fell into. Okay? So let's go. The cost of a long distance phone call is 45 cents for the first minute, 34 cents for each additional minute. If the total charge for a long distance call is $8.95, how many minutes was the call? Well, you got $8.95 equals, well, it's 34 cents each additional minute, right? Plus the 45 cents for the first minute, correct? Okay, so solve it. Go. And I want you to tell me what the answer is. All right, so if we solve this, we're going to be looking at it like, so we will minus the 0.45. So I'm going to take my calculator. I guess I can't do that. There we go. So that's 8.5 equals 0.34x, and then of course divide both sides by 34 cents, and x equals, let's see, divided by 34, that's 25, right? What is it? It's 26 minutes. Yeah, for the first 4 times I worked this problem, I was hung up on solving for x, right? I mean, I had the equation right. I was just, my brain wasn't saying, duh, you got that extra minute, right? That you put in there that you didn't count. Man, I was going like, I put some like 0.34 times x minus 1. I was taking care of everything. Then I was looking at it this way, and I still, so, but anyway, yeah, just don't forget to add 1. Your first minute costs a little bit more, right? So there. Anybody fall into the same hole? Anybody be honest? Yeah, I did too. Good. Good. Thank you. Appreciate that. Yeah. All right. Okay. Shane returned from a trip to Las Vegas with $400, which was 25% more than he had at the beginning of the trip. Hey, that's pretty good. How much money did Shane have at the beginning of the trip? Anybody want to take a stab at what the equation looks like? I don't know. Go. How about this? See, X is what we're trying to find, right? 25% more than what we started. X is what we started with, right? So, and it equaled how much? $400. So that's the easier approach to take. Because you can say here in our course, you can do split and doing different things with percents and divide and all this stuff. But let's keep it simple. Use Kith's method, right? So that's the most accurate way. So, well, you got 100%. You got 100% what you had plus a 25% growth. So that's 1.25, which would be 125%. 25% more money than what you had. So, yeah. So we'll divide it by this. Ladies and gentlemen, what did it come out with? And if you take 320 and times it by 1.25, guess what you'll get? 400. Yeah, I don't know. My brain didn't go that way. And I can't go that way tonight because I took some sinus medicine this morning. And at 4 something when I was driving to Athens, I about fell asleep. So I'm still a little bit. You can't do it that way. Okay, you can't do it that way. That's the easiest way. So yeah, my brain ain't working correct. Would it? I don't know. Normally I'd nerd that way, but tonight I'm okay with that. Yeah. Okay. Now here's the notorious train problems. Oh, don't throw your hands up. It's really not that bad. I'm going to show you what to do. I love train problems. I love it when they start in this station, go to this station, and they pass. How long do they, how long before they pass and one's traveling this speed? I love it. It's great. But the main thing you got to keep in mind is this. Distance equals rate times time, right? That's the old tried and true equation. D equals R times T. So guys, let's read this. Train A has a speed 25 miles per hour greater than that of train B. If train A travels 240 miles in the same time train B travels 190, what are the speeds of the two trains? Well, R is what we're trying to find, right? Correct? So we'll say R is D over T, right? Correct? And they gave us a relationship between the speeds. They said train A was 25 miles per hour greater than train B. So what we're going to do is this. We will say train A, and we're going to say x plus 25 over 240, right? And I'll explain where these numbers come from in a second. And then we'll say train B is X over 190. See, I don't know how fast train B is going, but I do know that train A is 25 miles per hour greater, right? So that's my, did I do D equals RT? Yeah. No. Stop. I set it up and worked it. Okay, hold up. Okay, so let me fix this since I found it's still going to make a fraction, right? We have a ratio, correct? But let me get my equation correct. Sorry. So our times are basically the same. So we basically have time equal to that. But when you solve for time, it's D over R. Now, that would mean that these equations need to be rewritten. They need to be flipped, right? So I will move, oh yeah, sweet. I'll move these out of the way and I'll say 240 over X plus 25 equals 190 over what? X. It didn't do it. My cross products are the same, right? I just didn't have it solved in terms of the right variable. All right. So y'all good with that? D over R equals what? T. And the times are the same, right? Same time, right? All right. So let's cross product. So that's 240x equals 190 x plus 25. And if we solve that, we get 190x plus, I don't know, what does that give me? 190 and 25, 4750. Y'all agree? Disagree? Confused? What? Talk to me, folks. No? $50? Yeah? Yeah, thank you. It'll go an even amount of times, you know why? Yeah, it's 50, 4750, right? Divided by 50. So what is that? X equals what? 95, right? So, but who is X? X is train what? B. So train B is traveling at 95 miles an hour. Train A is X plus 25, which is 95 plus 25, which equals 120. How'd you get it? You still did you have the same cross product?
Well, so I took the train A, which was what, 240?
Mm-hmm.
Then I subtracted train B, 190. I got 50. Oh, and then I divided 50 by 25 because that was the understood time, the extra miles per hour. Got 2. I figured 2 was the hours, the rate that I went. And then 190 divided by 2 was 95. 240 divided by 2 is 120.
Coinkydink. Now I don't know. Honestly, there's a lot of assumptions. We'd have to. These are all algorithmically generated. If you use that algorithm, that process again on a different one, on several different ones, and you still get the same thing, then you've got a mathematical process. That's probably true. But you lost me at 190 divided by 7. Seriously. I'd have to see it. And we can see it after class. I don't have a problem. I nerd out we. But, yeah. Are there more than one way to approach this to figure this out? Yes. Yes, there are. But I have found that if you just take it D equals R times T, figure out if they give you a relationship between one to the other. They've got one of these particular variables set equal as far as, one set equal to the other. So, and then that's kind of where we're at. Biggest thing is make sure you know who X is. X is train B, and then train A is X plus 25. Questions? Y'all good? So you've already played around with this section? All right, good. Anybody else? I'm just curious. You didn't get that one? What about the one with the interest? Did you get that one? Really? That's the one that made me do this until I figured out that, okay, yeah, and then I started writing up the equations. Yeah. Yeah. All right. This one's one. The length of a rectangle is 2 meters less than 2 times the width. So we don't know what the width is, so that's X. So 2 meters less than, so length equals 2X minus what? And then width is X. So the perimeter is what? 44. Find the width. Right? So that's perimeter equals 2L plus 2W. And then that's 44 equals 2 times 2X minus 2 plus 2X. Then that's 4X minus 4 plus 2X equals 44. That's 6X minus 4, 44. Check my math, folks. Did you get a fraction on this? No? Huh. Okay. What if I add? Oh, 48. Duh. I was going the wrong way. Okay. So X equals what? 8. So the width is what? 8. And it's 8 meters. Right? 8 meters. These aren't hard. It's just more of an verbal into an algebraic expression, right? And then take those and form equations with them. You know that less than up the front means it goes in the back, right? Less than a greater than up front goes to the back. If it's in the back, it moves to the front of the equation. Those things. Greater than or less than. You don't remember that? Yeah, if they're in the front, they go to the back, right? Right, and that got some head nodding. Yeah, good. Okay, sweet. All right. How many of y'all have worked this one? Use the information to find a linear algebraic equation multiple to answer the question. Mark and Don are planning to sell each of their marble collections at a garage sale. If Don has one more than 4 times the number of marbles Mark has, how many does each boy have to sell if the total number of marbles is 96? Okay, do we know how many Mark has? Nah. So in math, we make that an unknown, which is a variable, right? But we do know how many Don has, right? One more than 4 times the number. So that's 4X plus what? And they have a total of how many? 96. So X plus 4X plus 1 equals 96. Do y'all agree with that? Yeah. And then I've got 5X plus 1 equals 96. Minus 1, 5X equals 95. 19? Yeah. Okay. So X equals 19. So X is Mark. Mark has 19 marbles. And, well, Don has 4 times 19, which is 76, plus 1, which is what? 77. Or I could just take 96 minus 19, right? That's 77. Either way is fine. Look ahead. Nod. Okay. All right. Any questions? Y'all good? Yeah, we did 1977, right? Yeah. Well, I didn't wait. Say that again now.
How many does each boy have to sell in the total number of homes?
19 to 77.
It's just asking how much do they. I was reading it wrong. I was interpreting it different. Like, how many do they need to sell? So that
Oh, nah. It's this. Yeah. It's just another way. All right. Oh, sorry. Oh, well, if I know that this was 4 times 19 plus 1, plugged it back in. So here's my beginning stuff up there. Yeah. Okay. And write it out like I've got up here. Mark and Don, x and 4x plus 1. Because if you don't, when you get done working the problem, guess what's going to happen? You won't know who you solve for. Okay. Being organized, being neat on this, showing everything makes life a little bit easier. This one I didn't work, but I did write the equations for them. So Company A charges $20 monthly fee plus 10 cents a minute for calls, and Company B is a $10 monthly fee and 15 minutes for calls. So this is what I wrote, okay? Y sub A equals, and that's Y sub A, Y equals, right? The A is Company A, so the subscript is A. 0.10x plus 20, and then I'll put Y sub B equals 0.15x plus 10, right? Any questions about that? That should be straightforward, a linear equation, right? Now, how many minutes of calling in 1 month would make the two plans equal? Well, you got to turn around and set them what, guys? Yeah. And it says use M for minutes, but I use X, so. Uh, I think I got enough room. So minus 10. So that is, let me go up here and I'll finish it. 0.05x equals 10. And then, of course, divide both sides by 0.05. I got 200. So how many minutes would it make each one be the same? 200 minutes. Okay. And that's just multi-step, solving multi-step equation, variables on both sides. And then it says if a person makes a monthly average of 150 minutes of calls, which plan should the person choose? So it's basically Y sub A equals 0.10 times 150 plus 20, and that gives you, what is that? I don't know. 15 plus 20 is what? $35. So that's Y sub A, right? And then we'll do Y sub B. Company B is what? 0.15 times 150 plus $10, right? So that's 20 to 50 plus 10, which is what? So who would you go with? Company B, right? It's a little bit more cost per minute, right? But it's cheaper on the initial monthly. Will they flip-flop? Yeah. After 200 minutes, guess who's going to be cheaper? A. Because the two lines are coming. They'll intersect at 200 minutes, and then they'll switch places, right? So if you use below 200 minutes, then you know why Company B's your cheaper route. So, yeah. Verizon and AT&T used to play that game earlier in the 2000s. They used to play that game of initial fee at so many per minute, right? Who had the better deal? So, yeah. Okay, questions? Everybody good? Y'all got really quiet now that we're in a bigger room and spread out. It's cooler in here, but y'all stop talking. I don't know if that's because we're online or on the. They don't hear you. The only people's gonna hear you is you. So, all right. Here's the best problem of them all. Now, so when I read it, I scratched my head. I was like, dang it. How am I going to figure this one out? And then I got thinking about it. Okay, well, it's a simple linear. I mean, because we're not in quadratics or exponentials or anything like that, so we don't have to worry about it. So it goes back to this. I equals PERT, right? Principal, rate, and time. And for these, time is all the same. So time we ain't got to worry about. But it's I equals PR, and because T is nothing. Now, they want us to invest $20,000. His intent is to earn an overall 6% interest on his investment. Well, the interest you have to do I is 20,000. Yeah, 20,000 times 0.06, right? So what does that give me? 1,200, right? So basically, he wants to make $1,200. Would y'all agree? 20,000 times 0.06, like 1,200 bucks. So you got 1,200 bucks in interest equals piece of one times what? 5%, right? Plus principal 2, right? At times 0.09%, right? So basically what I have is 1,200 in interest, the principal 1 for account 1 at 5%, plus account 2's principal at 9%. They better give me at the end of 1 year, at the same amount of time, a $1,200 return so that it is overall a 6% interest gain for this guy. So who would still be going like, I don't know at this point? Yeah. Okay, guys, watch this. How much do we have? No. We want to make $1,200, right, off of these two investments, right? So how much do we have to put in? 20,000. So do we know what P1 and P2 are? Well, we know the interest. You're exactly right. We know the interest rate, but we don't know the principals, do we? We have to find them, right? So we'll do X for one of them. Well, how would I find the other one? 20,000 minus what? X, right? Yeah. That's it. All right. Let's say you gave me $10, or we got $10, right? You split it between me and this lady right here. So, but you don't know how much you gave us. My amount, right? X, right? Now her amount's going to be $10 minus mine, right? Okay, that's it. That's all we're doing. So, yeah, that's right. But in this one, it's 20,000, right? So what we're gonna do is this. We're gonna say, hey, we don't know. We know the overall amount was 20,000, but well, simple is define simple. For the second principle, it is 20,000 minus X.
So what is P1 then?
X. P1 to be X. It's some unknown, right?
Yeah.
Some amount. If it comes out to be, let's just for grins and giggles, let's say the X comes out to be 11,000, right? So if I do 20,000 minus 11,000, I get 9, right? which would be what the second amount would be, right? So all I've done was, here's an unknown, and have a total. Total minus that unknown would be the other amount. But your brain doesn't go there because it's initially it doesn't go there. So you got to kind of make it go there, right? That's why this is the very last problem in this section. It's here to mess you up big time, okay? And there's not, what, 16, 17 problems in the whole homework, right? There's not that many. And we've done probably the harder ones of it, those y'all that have done it, right? Was there any more that were harder than this? Yeah. This and then the train, right? Ooh, yeah. All right. But yeah, just distribute. Let's see. So I multiply this, right? And distribute to 0.9 or 0.09, right? Do it. You'll figure it out. Go. Solve it. We'll hit pause and let you solve it. We'll give you 30 seconds. Hit. So here we go. Help me do the math. So we're gonna distribute, right? Ooh, I can't do that color. Like this color. We're gonna distribute that way, and then I've got. Let me roll this up. That's 1200 equals 0.05x. Now, what's 0.09 times 20,000? 1800. Good job. Minus 0.09x, right? Y'all agree? So we're going to combine like terms here, which is going to give me negative 0.04x plus 1800 equals 1200. You go, well, Palmer, you got a negative. What are you going to do? Yeah, it's a zero. Yeah. Well, no, I won't never leave naked decimals. So if you see a dot in front of it with another number preceding it, then it's a zero.
Yeah, I'm used to doing this dot.
Yeah, you don't leave naked decimals. Cover them up. Yeah. I done a test in college like that everything was perfectly correct. He gave me a failing grade. Naked decimals. I thought I was going to come unglued. But I didn't understand at the time that it was an engineering, it was in the engineering class and it was over motors. And I just didn't understand what he was trying to teach me until after I blew up and lost my cool. And 3 or 4 days later. So we're going to move this over, right? So that's negative 600, right? Negative 0.04. So I got negative divided by negative, which is going to give me a what?
Positive.
Yeah. All right, good. Now you see where we're going. Well, hold up. We got to do that 600 divided by 0.04, right? And because it's negative divided by negative, we know that x equals 15 what? 15,000, right? So the principal in the first one at 5%, that was my x, right? So that's at 15,000.
So P1 and P2 is just to do with his money?
Yeah, he had 2 different accounts,
Okay.
2 different interest rates, but combined interest was as though he had a 6% gain in his. So that's the thing that's the curveball that kind of messes you up. Like, yeah. So if it's 15,000 in the 5% account, then there's how much in the 9%? Questions?
How do you know that it's 5%? Since the first exponent.
Right here. Here's my interest rate at 5%. Here's my interest rate at 9%. This is tied to account 1. This is tied to account 2. So therefore, P1 became X. P2 became 20,000 minus X. So based off the interest rate and the account information, the initial principles, I know which one goes where. So yeah, but that is a very important thing to see. Yeah, I would highly encourage you to work, I don't know, 3 or 4 of these. And I don't know about y'all, but it doesn't give you the right answer, does it? When y'all do it? It doesn't with me. Does it do it with y'all?
You gotta keep going until you get it right.
Yeah, I didn't like that. I don't like that.
Once you put one in and gave it the right amount, if you guess 3 times, then it would give you the right answer.
Oh, well, well, I can change it back. Okay, guys, I made a mistake. See that? See, I erased it. I had X's down here. I don't know why I done that, but I fixed it now. So just be mindful of that. Okay. All right. Any questions on this? So this concludes everything in the first chapter, right? Okay, so you ought to be caught up in the end of this, and this gives you a little bit more snippet of where you need to go. Yeah, 4 sections, or 3 sections. 4 sections or 3 sections? 4, yeah. Here we go. Chapter 2, section 1.3 deals with radicals and rational expressions. So we're going to look at things like the product property where you have, basically, you got a number. You can split that number up into 2 factors, right? Let's say like square root of 45. We can split up square root of 45 into square root of 9 and square root of 5. So that's basically what this first one's saying, right? And you can do it with any root that you want to. That's always good. And then 2, this quotient property right here says if you have a fraction underneath a radical, then you can split the radicals to be in the numerator and the denominator, right? But if you ever have a radical in the denominator, ladies and gentlemen, we're going to have to rationalize the denominator, and that we'll have to do some of that and talk about that. Now, absolute value property for radicals, the square root of a squared is a, or the absolute value of a. I don't know. I always deal with, if you take the square root of a number, you get a positive and a negative, right? Okay. So just want to make sure. It's only on odd roots that you have to worry about there just being a positive or a negative. It can't be both, right? So even roots, yes, positive and negative. Extended absolute value property. Nth root of a to the nth equals absolute value of a if n is even, and nth root of a raised to the n if a is n is odd. Yeah, okay. You have fun with that. We're just going to work some radicals. That's a lot deeper into math than really what you need to know, right? Any of y'all math majors? Nobody's math?
I'm going to major in English.
Huh? Yeah. Yeah. Anybody going to engineering? Yeah. Simplified form of radicals. A radical is simplified if, well, there's no factors that are perfect squares. I'm going to teach you how to simplify a radical, right? But I'm going to teach you how to do it with just looking at factors that are perfect square. A lot of times teachers teach you doing what's called prime factorization, right? Factor it down, tree it down all the way to prime numbers, and then group pairs, right? If you can group pairs, you can bring them out. Well, when you group pairs, what you're creating is a perfect square, right? You've got to understand that. So the prime factorization tree is more of a lower level strategy for simplifying radicals. So we're gonna take it up a notch, right? It ain't that bad. If you know your multiplication factor, you'll be fine, right? And then of course we said if you ever have any radical in the denominator, we got to rationalize it, right? Which means we're just going to multiply top and bottom by that radical. Unless it's a cube root or fourth root or something crazy like that, then we'll have to make sure we're good. Okay, y'all ready? Yeah? No? Y'all good? Yeah. All right. So, all right. 64 is what type of number? It's an even, yet good, but it's a what? Perfect square, right? So when it says simplified square root of 64, you basically are looking at plus or minus what? 8. Now, if it doesn't just take, if it will not take plus or minus 8, then they're using absolute value thing they talked about, right? Does that make sense? So just be mindful of that. But I'm going to tell you, yeah, that's if they're only taking the positive of it, then they're dealing with the absolute value of that, right? So, but I'm going to teach you plus and minus, right? That's just good math. Eight, 81, 100, right? Okay, that's up to 15. So now you ain't got to go up to 15. Do you know that 80% of radicals can be simplified from 4 to 64? And if you ever go above half of that number, then the likelihood of you being able to simplify drastically diminishes. So we'll talk about some things like that as well, okay? So know your perfect squares. That's the key. I'm not going to teach you prime factorization. All right, here we go. Oh, sorry. I know. Who'd have thought it? All right, so square root of 294, right? We got to simplify it, right? You said use product properties, blah, 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 to simplify this. Okay, guys. Square root of 294. This is how I teach it. We always start with 4 go into it because 4 is the smallest perfect square that's, you got square root of 1, it goes into everything, right? And of course, is square root of 0? Is it a perfect square? Yeah, because perfect square would be a number times itself, right? So square root of 0 would be, that's a perfect square, isn't it? By definition. How about that? Wow. So we're going to start at 4, right? Will 4 go into that evenly? Yes or no? Oh, no, y'all got calculators right there. Come on now. No? 4 won't go? Will 9 go? Evenly. 16? 25. I can go ahead and tell you 25 don't go. Well, what's 4 times 4 and 5 times 5? 4 times 4 is what, guys? No, 4 times 4 is 16. 5 times 5 is 25. So 25 I know won't go in there because it didn't end with a 0 or 5, right? 36. 49. Will 49 go? How many times will 49 go? Okay, so we're going to break this up. This is great. It's wonderful. And you're going to get mad. You're going to go back home to your math teachers and you're going to say, why don't you just show us this to begin with? So we broke the square root of 294 up into the square root of 49 times square root of 6. Because when you multiply radicals, it's outside to outside, inside to inside, right? So we haven't violated any mathematical laws. So square root of 49 happens to be a perfect square. Now, so that's 7. Can I simplify square root of 6? Well, it's as simple as this. With 4 going to it? Nope. Next one is what? 9. 9's above it. I'm done. So 7 square roots of what? Done. It's simplified. And it's as simple as that. And a lot of people make simplifying radicals some horrendous thing. But I will tell you this. Let's see it. TI-36X Pro will it'll simplify it, and you can multiply them babies. You can get all crazy with it, and it'll give you the answer correctly. Just saying. Huh? Ooh, do you got one? Turn around. Ooh, yeah. You put that thing in there. Square root of 294, hit enter, see what it says. Now, it may give you a decimal. If it does, hit the button above it, and it'll give you 7 square roots of 6. Yeah. So if you want to see the decimal of that, just hit the button above it, which is the approximate, and it'll give you the decimal, which would be, that's about, I don't know, hold on, that's about 2.7. So it ought to be about 15 something. What was it? Yeah, just the button above the enter. Should have 2 catch waves, right? That button right there. Huh? There.
Okay.
That one.
Okay.
No, don't hit enter. Just hit that button, and it'll flip between. Okay, so it's 17. I was off by 2. Okay, any questions? All good? So do you understand how to simplify a radical? when you're dealing with radicals, you must always, before you say this is my final answer, you must always make sure that your radical's been simplified.
What if you go all the way up to 15?
Well, I go all the way up to this number. Well, what's half of 294? Well, that's basically like 150, right? Right. So if I get over 144, guess what? That's 12 squared, right? What's my likelihood of something above 144 going to that evenly? So that's why you'll learn things. You won't. Unless it's a perfect square, right? Yeah. Okay. Let's go. Yeah, simplified expression. Well, we talked about multiplying radicals, right? We said what? Outside to outside, inside to what? Now, that may not mean anything to you, but watch what I'm about to do. That's what I'm talking about. Do you see what I've done right there? Does that make a little bit more sense? A squared root of B times C squared root of D, then A times C and square root of B and D, right? Outside, outside, inside, inside. All right, do not, never, ever, unless you just like to do math over and over and over, do not simplify it to begin with unless it's a perfect square, okay? Because what you're going to end up doing is you'll simplify it, then you'll have to multiply it, then you'll have to simplify it again. So you're doing a lot of work over and over. Only do that if the government's paying you, okay? And then do it a couple more times. No, I'm just being facetious. Okay, so that's really the square root of 120, right? Yeah? Okay, so what's my thought process? What am I starting with? 4. Will 4 go into it?
Yes.
Okay, so if 4 will go into it, guess what else I'm going to check? There's, because if you look at multiples of 4, 16 sometimes works, right? So if 4 go, I'll also try 16. Doesn't hurt. Will 16 go into it evenly? Anybody?
No.
No. So I'll just do, okay, square root of 4. I don't have to pick the largest factor. I don't have to do the GC, greatest common factor of it, I just don't. How many times will that go square root of 30, right? Yeah. All right, so we know square root of 4 is what, guys? 2. Now, can I simplify square root of 30? Well, let's see. Will 4 go? 9, 16, 25, boom, done, right? Because next number is 36 and it's over. So, ladies and gentlemen, 2 square roots of 30. Are you tracking okay? You sure? Because I am talking 90 miles a minute. They cut off the Pepsi machine over there in the thing. I don't know why. I hate to tell them, but I pass several convenience stores between here and there. And they sell the liter bottles. Yeah, I'm okay. Huh? Do it, guys. Just don't have too much fun. Get you in trouble. All right. Now, what do we got to know about adding or subtracting radicals? What's the big number one key thing? Anybody? No, that's multiplying. Outside, outside, inside, inside is multiplying. Like what? No. Okay, that's a C and that's an A. I promise you that's a C and an A. There you go. Like radicals, right? So just make sure that things are the same. Now, I will tell you this. You better simplify them before you start trying to do anything with them. And if you look at it, you can find things that may help you to get there sooner. For example, square root of 6. Can I simplify that? Nope, sure can't. Now, if there's even a chance that I can add these two together, I better have something that's the square root of 6, right? Is there something times 6 give you 54? 9's what type of number? How about that? Do you see how the answer was right there in front of you on what you needed it to be? But you had to know what you were looking at, right? So here we go. 4 square roots of 6 plus 5 square roots of 9 square roots of 6, right? Those are all tied together by multiplication right here. So that's 4 square roots of 6. Move this up. Plus 5 times 3 square root of 6. I got 19 square root of 6. 4 and 15 is 19, and then of course square root of 6. It's kind of like treating it like like terms. Once you simplify, you're good. Yeah. Oh, right here. What's the square root of 9 simplified down to? 3. And this is all tied together, right? Yeah. So this is normally what you would cover about 3 or 4 days. We're doing in 15 minutes. Welcome to college, right? It's cray-cray. All right, so there. 3 squared root of 6 times 5, that's 15 squared root of 6. And then 15 and 4, because the radicals are the same and they're simplified, right? They're simplified, so I can just add them. What's up? The green. Okay, so I split 54 into the square root of 9 and square root of 6, right? Square root of 9 is a perfect square, which came down to 3. 5 times 3 times square root of 6. Those are all tied together. A radical? Well, see, when I simplify, when I find a perfect square, the radical goes away, right? Because square root of 9 becomes 3, not the square root of 3. So, well, here. There's your dot. So really these, no. When you multiply radicals, inside to inside, the radical's still there. But we're simplifying here. We're simplifying. Okay. Yeah. Yes. That's right. Yeah. And when you add or subtracting, you want to simplify because you want to combine like radicals, right? But on multiplying, you want to multiply, get everything done, and then simplify. And then you may end up with something that you can combine, right? So don't ever discard, it's a multiplying problem. It may end up that you have like radicals and combine them at the end. They may throw a curveball at you. That's right. All right. Fourth root of 243. Now, guys, I don't know about you, but I can do cubes. I can do, well, I say, yeah, I can do squares and cubes. I'm not that fluent in fourths. You know what I'm saying? Things raised to the fourth power, or fifth power, or sixth power. So here's what you do. 1 raised to the fourth is what? 4. No, it ain't 4. Yeah, my brain went. What did I do? It's 1, right? 1 raised to any power is 1, right? Snap. Yeah. Okay. So 2 to the 4th, 16. 3 to the 4th. Anybody? Huh? Shoot. You sure about that? Huh? 81. Yeah. 27 times 3 is 81. All right. 4 to the 4th. Whoa, I like the way you think. 256 always comes back in if it's even numbers. You ever realize that? 256, 512, 1024, those things. Yeah, those numbers always come back up. Just, number theory. Okay, 5 to the 4th. Anybody? 5 times 5 times 5 times 5. That's 625. That's 25 squared. 625, right? Which would be 5 squared raised to second, which would be 5 to the fourth. All right, so that right there should be enough for us to do, right? So if we're going to simplify the fourth root of 243, excuse me, we can't do that. 1681, 256, 625 better be a factor of it, right? Yeah, because those are perfect what? Nope. Perfect fourths. Fourth, right? Powers of four, right? Perfect power of fours, right? Yeah, we don't have a really good name for four, do we? Like squares and cubes and four. It's just four. Huh? Quad? Nah, I don't think so. Yeah, I don't think so. Not in powers. Okay. Polygons? Yeah. Okay, so somebody, will 16 go into this? No? Will 81 go? 3 times 1. How about that? Yeah. So we listen. It's okay to smile. It's math. Get happy about it. So the fourth root of 81 is how much? 3. Now, can I simplify the fourth root of square root of 3? I mean, fourth root of 3. Can I simplify that? Nah. So guess what? My answer is 3 fourth roots of 3, right? Yeah. Now, did we do anything different than when we did when we looked at squares? Nah, nada. We found one of the factors that had to be that, right? So here's what I would do if I were you. I would take an index card if I were you, and as I was working these stuff, and I come up to things like this, boy, I'd write that down on them. You know what? And then I'd punch a hole in the end of it and get one of them there rings that go around it, right? Yeah, that's what I'd do. Right. I'd take index cards and on things like this. Yeah. Well, I didn't want to make it sound obvious, but I would have a set of cheat notes, things that I could quickly reference, because if it's really accessible to you, you're going to be able to find it and you go. But if you go, oh, I'll work the problem, I'll have it, I'll flip back to it. Well, guess what's going to happen? You're going to run out of time, right? Work smarter, not harder. Okay. Oh, that was the same thing as this one, wasn't it? Yeah, I apologize for that. Let me make that go away. Okay, rationalize the denominator. We're looking at square roots, right? So, and the radical's in the denominator. And we can't have a radical in the denominator. That's a big no-no. So we got to do a process that's called rationalize it, right? So we've got 3 over the square root of 5. Now, what I need to do is I need to find something that I can multiply the square root of 5 by to get to be, because it's a square root, I want to make it a perfect square, right? So, squares kind of are crazy in this sense, because once we have it, we just multiply it by itself, right? And life is great. But when you get to the third root or the fourth root of something, then you got to think about, what do I need to multiply it to get it to be a perfect cube or a perfect fourth degree number, right? So just kind of think about that. What this gives me is 3 square root of 5 over square root of 25. And folks, the square root of 25 simplifies down to what? Yeah. Now, I'm going to erase that. That's just poor writing right there. Can I simplify the square root of 5? No. How do you know? Nope. Because 4 won't go into it. Next number's what? 9. See, you got to know why you can say that it can't be, right? Know that you know that you know. Don't just say no. No, it's not. Why is it? All right, so that's really what you're doing, right? Rationalize the denominator. A lot of you, if you went through an Algebra 1 class, you've done that. You went to an Algebra 2 class, you've done that with some binomials as well, with conjugates, right? So anyway, any questions? Y'all good? Is your brain mush by now? I'm sorry. We must carry on. Okay, so the square root of 900, a to the fourth. Okay, so break this baby up, okay? Take care of the square root of 900, and then we'll come back and do a to the fourth, because it's pretty simple, and I'll show you what to do, and it all hinges on that. Okay, so, man, what would that be? 900 is a perfect square, isn't it? That's 30 times what? 30. Because if you think about it, I could do a square root of 9, and then it's square root of 9 times square root of 100. Both those are perfect squares, right? So, yeah, it's square root of 30. Yeah? Okay, now, so that's simplified down. That's because 900 is a perfect square. Now, they used to teach you this. They used to go, okay, expand it out, right? And then come in here and group them. How many groupings of A's do I have? 2. Why am I grouping by 2's? Because the root or index is a 2, right? So that tells me how many I have to have together in order to pull out one of those. So basically I can pull out 2 of them, right? With none left in, correct? Y'all agree? So, but let me tell you how to work this a little bit quicker. See this root? How many times will 2 go into 4? Thank you. 150 million%. Just like that right there. So you either got it going evenly. If it's a square root of 2, index of 2, it's either going evenly or it will have a remainder of 1. Let's say it was a cube root. How many times will 3 go into that power? It'll go into it evenly or have a remainder of 1 or 2, right? Well, it would be, let's say, for grins and giggles, let's say this is 3 instead of 2, and let's say that's 7, right? So 3 goes into 7 how many times? Twice, so there'd be 2 A's out with how many left over? 1. Let's say that's a to the 8th. 3 going to 8 how many times? Still twice, but how many left over? 2, thank you. So you're just leaving your remainder in there. That's all you're doing, right? Yeah. Or you can just expand them out. This is expanded notation. The index or the root tells you how many groupings, how many numbers I have to have in order to make a group. And the numbers are 2. So I got 2 A's here and 2 A's here. How many A's do I have that are grouped? So it's A squared. Either way, train of thought is fine. But you got to make sure that you're having those trains of thoughts. If you don't, pack it up, go to the house. It goes back underneath the house. Yeah, sometimes they'll say, this one had a date, so it came out. That one had a date, came out. If you had one that didn't have a date, it had to stay home, right? There you go. Yeah. But we're going to deal with much complex than square roots, right? So you can't, but you can play the dating game. It's, so anyway. So the answer on this is 30a squared. Okay. All right. Yeah. All right, good. So, that little note card that I said make, it had all these powers, right? Now, do you understand why I said make it? Now, you got to tell me some more. So I got 1, I got 16, I got what, 81. What was it? 256, 625, right? Okay, good. Now, 16 would go into that, right? 3 times, right? Yeah, okay, so you can see it. So it's the 4th root of 16 times the 4th root of 3. Man, that could not have telegraphed a better problem. This is wonderful. Okay, so what's the 4th root of 16? No. 2, right? Because 2 times 2 times 2 times 2 is what? 16, right? Yeah, so that's 2. Can I simplify the 4th root of 3? No. So that's going to stay there, right? No, it ain't square. It's the fourth root. See these numbers right here? These are all powers of what?
4.
Of 4.
On that whole system.
That's why I said it makes them what?
No.
No cars. Yeah, man, it'll train wreck you in a heartbeat. Because you ain't used to those numbers. I mean, seriously. I mean, how many of y'all walk around with powers of 4? Man, I can do powers of 3. But that's because I have to teach it. So, I know that's why you need to, yeah, now you know. Okay, so I've got this, right? Now, here's the thing. Ready? I could expand that y 7 times, right? And I'd have, how many would I have to have in order to make a grouping? How many y's would I have to consolidate to make a grouping? How many would I have to gather to make a grouping? 4, that's exactly. Where'd you get 4? From the, not the power root. That number is called the root or the index, right? It's the fourth root, okay? Now, so I could pull out 1, right? Well, how many's left over? 3. So watch this. How many times will 4 go into 7? Once. How many left over? Thank you. Yeah, not square root. Fourth root of. Yeah. So I got one of them that'll come out, right? But I also have how many's going to stay in? 3 of them, right? Yeah? Yeah, now that one will make you scratch your head a couple times. You know why? Because it's the fourth root. We just don't deal with the fourth root that much, do y'all? Square roots, baby, we can walk a dog on it all day long. Not the fourth. But that's why we have that little thing, right? 4 goes. Nah, no.
But with that, could we use that principle?
No, ask yourself how many times 4 go into 7? 1 time. Well, how many left over?
The random 3. I just point that out, like trying to shortcut it.
Nah, no, bro. That's as much a shortcut. You can't break down any more than that. You okay right there? Let that dog hunt. All right, y'all ready? Snap, crackle, pop. You know they were going to give us one of these, right? But don't fret. Don't fret. Why? Why do you not need to fret? Hello. They're both perfect squares, right? So, but I can rewrite it like this, right? And I highly encourage you to rewrite it like that because life is going to get much easier. So that's going to be 5x squared of x over 6 squared of x, right? Now, I've done it really quick. But can I have a radical in the denominator? No. So that's going to give me of course, that's really going to give me this, right? And that, ladies and gentlemen, is still going to give me this, right? Where'd the cube go? Well, 2 goes into 3 how many times? Once. With how many left over? So I went ahead and simplified that from the black to the blue up top, right? Man, I jumped a lot of things. And then I went square root of 36 is 6, but there's only 1, right? How many do I need for the x's? I need them to be 2 or more, right? So that x just stays in there, which is going to cause me to have to rationalize it, right? And if I do that, that's going to be square root of x times square root over square root of x, right? Anybody know what the principle behind rationalizing really does? Does it really change the value? Why? Why has rationalized the denominator never ever changed the value of the overall number? Huh? No. Ladies and gentlemen, what's anything over itself? Thank you. The square root of x over square root of x is nothing more than what? I'm creating an equivalent fraction. That's really what we're doing. But we don't see that because we're too ingrained in rationalize, right? So here, square root of x over square root of x, because I got to get rid of that square root of x, right? Right? So that gives me 6 square root of x squared, right? Anybody see what's going to happen to that x squared? What's going to happen? It's going to come out, right? See how I got the 6x down here in the blue? Now, 5x and the square root of x squared, what happens? 2 goes into 2 how many times here? Once. So one of those x's come out, leaves me with x times x, which gives me x what? Now, most people would stop right there. But nope, you can't. Why? Amen. It's not simplified. So I got like basis, quotient power rule. Y'all remember that first thing? Got 2 up top, 1 on the bottom. They cross out, right? 2 minus 1 is 1. Hello? 5x over 6. Now that looked like a very simple problem. But do you know how many properties of math we went through? 7. So, you got to be on your game. How do you get on your game? Know what you know what you don't know. You better get your unknowns known. Now, how do you get your unknowns known in a college class that we're trying to cover 2 sections a night, twice a week? You better go ahead and preview what we're doing. It's like watching a movie. The second time you watch a movie, you'll pick up on stuff you didn't pick up on the first time, right? But if you come in here and it's the first time you're seeing this, you don't know what to ask. You don't know what to ask. You don't know what to think. You're just sitting there like, Lord, please let this ride stop, right? That's what you do. It's like that roller coaster you're on. You're like, no, I'm too old for this, right? So, all right. Y'all good? All right. Oh, man. Yeah, you know I told you be careful because sometimes square roots kind of throw things and it kind of makes you appear that you have to multiply by the same thing, right? Well, here's that problem. Okay, so we're going to break it up, right? It's cube root of 5x over the cube root of 4y. Now, guys, I need to create a perfect cube down in the bottom of it, right? When I rationalize it, I have to rationalize it by something that's going to give me a perfect cube. So I know from a variable standpoint that, guys, I need to, that's 1, I need 2 more, right? You all agree with that? Multiples of 3s. Now, let's think about this. We got 1 cubed equals 1, 2 cubed equals 8, 3 cubed equals 27, 4 cubed equals 64, 5 cubed equals 125, right? So, what do I need to multiply 4 by to get it to be a perfect cube? No. My bottom needs to be that. And see, that's going to mess with you because we're so ingrained with dealing with square roots and rationalizing. You multiply it by the number to get you a perfect square, right? But not this. This has to be, when I get done rationalizing this joker, this has to be a perfect cube. And the only way you can get a perfect cube is if you, well, I could. Yeah, sorry. There's 2 possible paths on this route. My brain went to the 64. Yeah, you can multiply it by 2 because 2 times 4 is what? 8. Let's do that. Good catch. I like the way y'all think. But it's something other than who? Do you understand? That's what I got to get through to you. You understand me? All right, good. So, 16 would work too, right? It's great. So I'm going to do this up here. That'd be 2y what? Squared. All right, so let's go to blue. So this is going to give me down here. Let's go right there. Sound effects are extra. 5 and 2 is what? 10. X. Right? Am I missing anything? No? And then this one is which gives me can I do anything with the numerator? Anybody see anything I can do with the numerator? I don't have any perfect cube that go into 10, do I? Because the smallest one besides 1 is what? And 0, right? And is 8, right? 8 won't go into 10 evenly, so therefore we can't do that. I got an x to the first. Well, I have to get, huh? No. There's 2 of them. How many do I need? I need 3. That's right. That's when you're young and your parents send you out with your sibling on a date. You got to have 3 in that one, right? Yeah. So, yeah, you ain't going by pairs. You got to have 3 to be able to go out. That's a rule. So, any questions? All right, take a deep breath. Because we are covering a ton of information. Radicals. Now, this won't. This is on the one that's going to be the following week. Yeah. Why is it 2? Okay, so we had to multiply something by 4 to get it to be a perfect what? Cube. It had to be a perfect cube in order to simplify, right? Because if not, the radical would still stay in the denominator. And that wouldn't benefit us to rationalize it, right? So I chose 16 because I was going for 64, right? And if I did, then I would have to simplify this up here. Probably. So.
How does that, call it the root number? How high does it go with that next section?
Oh, it just goes forward.
Okay.
No, listen, I picked a lot more problems than we probably should be working for this. But I picked enough problems for me to feel comfortable that if you got exposed to it, that you had enough problems and opportunities to be able to ask questions. Okay? At the end of the day, if we get to the last unit and we're like a section away, okay. I'm not going to sweat it, but we're going to make sure that you understand the math as we go along. So that's the biggest thing for me. Okay? All right. Oh, my jeez. I know, man. It's like you have to rewrite them. Y'all remember rational exponents, right? Y'all know what I'm talking about? Here, I'm going to give you a crash course in it. Ready? There you go. Yeah, well, no, it's more of a roadmap. It's a property. It's rational exponent. Basically, understand rational exponents. To rewrite a fractional power is to have a radical. So that's why this is cool. Ready? We'll nerd out. Like, this is why when you take square root of x squared, you get what? X. You know why? Because really this is, ready? Yeah, wait. Yeah. Oh, yeah. It's 2 over 2. What's 2 over 2? 1. Because really this is what? Yeah, my brain went. It shut off midstream. Sorry. Square root of 2 of x. Square root of x squared is just x because it's really 2 over 2, right? And 2 over 2 makes a what? A 1. bottom number is the radical root of the radical, and the top is the numerator, is the power. Sorry. Okay, so first things first. This is really, let's rewrite this joker. Because if you don't rewrite it, guess what's going to happen? Not much. Okay? So this is really, there. Does that make you feel a little bit better? And I put the 2 there, right? So that you could see it. And of course, this is going to be 196. And 196 is a perfect square because it's really 14, right? Yeah, how did I get that? Yeah. 196 is a perfect square. 2 goes into 3 how many times? 1. So I got 1x coming out with how many left over? Thank you. There we go. You've got to get into the habit of, okay, rewrite it. Get it into something that you're comfortable with, and then go play the game. Because if you try to manage that, it's going to be hooju mathematics. And that's bad. Okay? All right? Sweet. All right. Oh, good. All right. Now, you can do this on the calculator. But you can also do it where? On paper, which is excellent, right? So that's really the square root of 9 what? Cubed, right? Now, sometimes you'll see people do this. Right? There's 2 ways to write that. Either put it on the 9 or what? Bring it out, right? Or put it as it's raised to power, right? So really, if I was to do that, that's really 3 cubed, which is what? 27, right? So if you take 9, raise it to the 3/2 power. Take 9 on your calculator and raise it to the 3/2 power. I guarantee you should get 27 if you put enough parentheses on there. Take that power and make sure it's a fraction of parentheses. You'll be okay. Yeah? Sweet. But that's really the square root of 9 cubed, right? And this power, see, I don't like that power. You know what I'm saying? That's just mean. So I took the power and put it out. It's an alternate rewrite. Correct? Y'all know what I'm talking about? Take the power, put it at the outside. So the square root of 9 is 3. 3 cubed is what? 27. It's just a technique. All right? But if it's a technique you've never seen, then you're not going to be able to go there. So that's an adequate enough problem to do. Will you show him on that? Show him on his. Will you show him in his? Yeah. All right. Anybody else? Y'all good? When you type this 9 caret top, open a parentheses and go 3 divided by 2, close parentheses, and then hit enter. That's what's going to make the difference. You got to make sure you got your parentheses. If not, you will cube 9 and then try to divide it by 2. And that's not the best thing yet. Right? That's definitely not what you want to do. Okay. So I put one of these on here. And I think we're just about at the end. Yeah, we're just about at the end. Okay. I put a negative power on here. You know why? Because there's 2 of them in your homework. So right off the bat, what happens if you have a negative power? What's the big word? Starts with an L? No, starts with an R, ends with an L. Reciprocal. Good job. So basically all we're going to do is this. We're going to say 121 over 36 raised to the what? 1/2, right? I took care of this negative there, right? With negatives. So, and then I'm just going to, see this is square root of 121 over the square root of what? Which is 11 over 6. It looked more complicated than what it was, but you had to understand how to handle that negative on that whole fraction, right? You just take the reciprocal of it, and you're good. Now it changed to a positive power. And of course, that's 1/2, so that's really the square root of those numbers raised to the first power, right? The denominator's the root or index, and the number raised to power. last but not least, and then we have covered 2 sections, right? Which is what we needed to cover tonight per pacing guide, right? Good. And we've got 2 minutes to spare. That's it looks like that looks like a 4. Let me fix that. That is a 11. That's really, guys, that's really 121 raised to the 1/2 over 36 raised to the 1/2. There. So it's, yeah, power to a power, and then you just rewrite it as square root of 121, right? And then square root of 36, because the denominator is a 2. I got one more thing to show you. One more thing, because you need this, and you'll be set. Okay? Since I gave you a really nice room with some AC, and we can spread out and not be like a sardine can, you give me 2 minutes? Yeah, y'all wonderful. Thank you. Okay, look at that in the bottom. That's a binomial, right? But it's got a radical. Man, I hate that. So what we have to do is this. We have to multiply top and bottom by the conjugate of that. The conjugate for a binomial is take the same thing and just have a negative in it, right? It's like a difference of squares. It's really what you're creating. 2 factors that are difference of squares. The linear term goes away, right? So the linear term goes away, then you don't have any radical and it gets rid of it. So that would be 2 minus the square root of 3, right? Of course, guys, we're going to have to multiply, right? Not a big deal up top, right? So I can do this. So let's do that. That's 8 minus 4 square root of 3, right? Now, ready? This is cool. Take this one times both of those, right? So that is 4 minus 2 square roots of 3. Then I'm going to take the square root of 3 minus both of those, or times both of those. That's going to give me a 2 square roots of 3. And then, of course, that'd be a negative square root of what? 9. Note that these 2 little jokers right here go to what? They go to cancel out. Good. And then this gives me 8 minus 4 square root of 3 on top. This gives me, well, the square root of 9 is what? So this is going to come down to just be negative 3. What's 4 minus 3? 1. Can I simplify square root of 3? Nah. Where? Up here. Yeah, it's 4 times 2 and 4 times. So that's an outside, and square root of 3 is an inside. So they just get married. They just come together. It's like 2 and x. They become 2x, right? 4 and square root of 3 just becomes 4 square root of 3. So I can't do anything further than that's what we've got. This is an outside. That is an inside.
Well, what I'm seeing when you distribute it, like 4 going into negative, like a negative.
Yeah. 4 times negative 1 is negative 4, right? And then square root of 3 doesn't have anything it's multiplied to. So it does that. All right. Y'all good?